Welcome to episode 2 of a beginner playthrough tutorial thingy on Vulcan, as crazy as that may sound. I already changed the time scale again, so this is a direct continuation from before. We have almost 20, we have a bit above 24 times the normal day duration. It's a bit more than 8 hours. 6 or 6.5 hours of that are already over. That's why the sun is in the zenith. So what we're doing here, we're trying to build an AC chain to be able to cool down the room. The room is currently evacuated. I'm just constantly having this AC, this active vent running up here, which evacuates everything. That's why the airlock isn't yet live, because it makes it easier for me to just control this manually. First, we need some resources. So basically, the video starts with everybody, look at me doing boring stuff. And that's what it is. But that's what it is. So let's get into it. Copper is one of the most needed things right now. And no, we have no more mining charges, so hard labor. Once I'm hopefully capable of creating the heat and pressure, particularly the heat required to make Inva and Constantin, I'll be able to upgrade the manufactories, which will allow me to make the heavy mining drill, which is the fastest mining drill that you can have of the three. This is the second fastest. The third really fastest is heavy mining drill is a lot faster than this one. Again, we're playing on easy mode, but on Vulcan, and the time scale is slow, otherwise everything is normal and real, and so everybody can play this. And so I hope some beginners will actually feel inclined of following this. Vulcan is one of the most engineering heavy worlds there are. For example, here you don't find water, but you can make water because the atmosphere has volatiles and CO2. You can pump the CO2 into your station. You have to cool that down. That's what I'm currently working on, getting some AC going. And then the plants will convert that into oxygen. Then I combine the oxygen and the volatiles with H2 combustor, yeah, which will give us water at 2000 degrees and some pollutant and so forth. Then I have to cool that down in turn and so forth. So that's how to get water. How to get oxygen, I already just described implicitly. Beep. Testing, alright. Oh. Now, since we increased the time scale so incredibly, so that the day will be so much longer, the plants will have to be on their own timer because they need some light during their 20-minute day, which is still a 20-minute day, and some darkness. So for that, I have to either turn on and off light manually. Actually, I intended to place some barriers under the roof so I can pull portable hydroponics back and forth and thus give the plants shade or light. Anyway, we need to manually time that. So the other solution is to have a grow light and to control that manually or with IC10. And since I have the materials to actually program that, I want to get into that in this recording. So the other one, which was about 6.5 hours, it was this morning for me. This is on today's Saturday, and now I'm doing the next step. Cobalt. Oh, that's good. If you want to make your pill, the thing that will heal you, we already have one, okay? Then you need cobalt and silver and ferns. We don't have ferns, that's a plant, but you would have to combine that in a chemistry station, or what's its name? Then you get another pill. But you can also make a cryo tube, which is for reviving people once you do what the description tells you, to produce temperatures of minus 160 or so degrees Celsius. I don't know what exactly it is. I think it's in the description of the Stationpedia. But if you just want to heal yourself, all you need to do is put that thing up, turn it on, open it up. On the back side there's a pipe valve, there's a pipe connection to open it up to the room's atmosphere, if the room has normal breathable atmosphere, and go in. You will go unconscious, but you can still control yourself, as in you can call yourself back and get up and get out. But during this process, while you're gone, you will be healing fast, rapid. So that's the endless solution, instead of having to get materials to make that happen. I need to think about ways to control the temperature of that furnace more, I mean, in less dynamic, opportunistic fashion, like it has been in the previous video, where then I suddenly said, oh my god, we have steel! But more controlled, more intently. One way, of course, would be to just store some gas under high pressure in a tank at a high temperature. So if I need high pressure, high temperature gas, I would just get it from there and that's it. But it would be better, of course, to have fuel. You know, fuel gas, 1/3 oxygen, 2/3 volatile, that can pump that into the furnace, and that will then be burning with all the waste gases that come with it, which is not ideal for furnacing purposes. But I don't care. I've been doing it like this basically my entire stationeering career, so to speak. So that's not a problem. And the oxygen we get from plants. We already have the switchgrass. That's plants which I think give you lots of fruits, basically. So when they are done, you will not just get one plant. You will be able to multiply. You know, this is for getting a full greenhouse, basically. I think that's the purpose even of why you have the switchgrass on this planet. Why you start with that. But first we need to get some CO2 in there, into the station from the planet. We already have the filtration unit set up for that. It needs some more power. For that I need copper, so copper is the primary concern. I just realized I need to mine more of that. And here we go. Oh. Stay. And we need to cool it down. That's also a thing. Oh, it's full. And the idea there is to just cool down the station, which I have to do anyway. This is one of the reasons that I often store gases in tanks that are not insulated, because if my station is already taking care of the temperature, then I don't need to cool the gases in the tank. I just need to make sure that I'm not overwhelming my station's own cooling system with whatever the tank has, because if there's an uninsulated tank, then obviously it will be bleeding thermal energy into the station, or vice versa, depending on the situation. A bit more of this, and back home. Oh, one thing that I forgot. Is this thing still on? No, it's not. Now it's on. Now it's off. Oh, while I'm at it. What I forgot is in the lander here we have some more stuff. Here we have some water bottles. And here we have some cereal bars. Yep. Do we need to smelt some stuff? Yes, we do. Copper, for example. And then after that, some copper. And some... Wait a second. Is the recipe here complete? 50, 50, yep. And, well, then some more copper. And some gold, why not? And some gold. And some iron. And some iron. Nice stack, huh? And all of that will be smelted automatically because we have this logic thing going on where this chip is reading, is there something in the import slot? This chip is reading, is writing to that device the activate button there, and the value that is writing there is identical to what it's saying about the import slot, and this is just for turning the thing on and off. Later I will just do that with programming. But first we need to solve our little temperature problem here. Out there's 1000 Kelvin, which is warm. No, it's not warm. It's hot. So now that this is smelting something, we should be able to observe here that the pressure in our little tank is increasing. I wonder why the pressure is always falling again. Maybe it's an equalization thing. It's pushing and then it's no longer pushing, so the tank pushes back and then equalizes. What temperatures do we have here? Can't see, but in the tank we can tell almost 20 degrees Celsius, some volatiles, some pollutants, some CO2. So a colorful mixture. Not quite safe, but also not explosive. Alrighty. Now that we have some copper, why is the copper down there? Shouldn't it be like here? Bop. Yeah, there's no room here though. Okay, we need to make more of these, which means that we will need steel. I don't know, let's take a steel survey. How much do we have? We have here 49 grams, that's nice. 27 grams, none. 20 grams, looks good, okay. Then make some more insulated pipes because we want our AC system not to bleed its thermal energy into the room. That can go in here now because one slot was freed. Yep. So insulated pipes, this will be 27 of them, and that's not too many. Okay, the idea here is, let me first get 2 passive vents, or will I need an active, will I use an active vent on one side to accelerate the process? I don't know, I think yes, that's usually a good thing to do. When you have a filtration unit or an AC, if you wanna get shit done, then you wanna push for it a bit, you know? So we need another active vent. I appear to be hungry and thirsty at the same time. Don't underestimate this because it will indeed do double damage.
Hunger caution.
Multi-kill. What's happening? Didn't I say active vent? I clearly remember doing so. Okay, I do have some copper here. Great, because we need cables. Didn't I have an active... Yeah, there it is. There's an active vent. You cannot connect the active vent directly here to the input because that thing is a device. Oh, and the active vent also is a device. You cannot connect devices directly to devices. You always need some connector typey thing between that. Yeah, soon we're gonna have breathable atmosphere, and then we're gonna hear something in here instead of this constant silence. Okay, now a pipe. So these pipes, like I said, they have a maximum pressure capacity of 60 megapascals. The active vent can produce basically any pressure, but it has an automatic pressure protection when we turn it to inside 50 megapascals. This is a level on which these pipes will already start screaming, but that screaming is only as a gameplay element to teach the players, hey, this is something that can happen, so you want to look out for that. This is not really a problem. One moment, please. Goddamn fucking wall here, man. Get down. So I know the differences are in the details, and there's really a quality question. But in principle, I don't know why people are getting $300 microphones. Mine cost $10, and I just clamped that between my headphones and my head, so it's very close by. And then some work with limiter slash compressor in Ops Studio and some equalization. Okay, let's continue the construction of these thingies. This one has power. This one has power. Okay, now we need to pipe them up and then make sure that the pipes actually have some gas in there, else this won't work. Oh look, a fire extinguisher. Which is interesting because it has a canister. And that's a liquid type canister. Why would there be a liquid type canister in there? Is that water? No. It is CO2. Under, well, it's not very high pressure, it's 1 megapascal. Oh, but it's 12 liters. Okay. And that thing is not insulated. I wonder if it can actually explode. That would be a surprise. Maybe I should use this thing a bit. How full is it still? Is at 12 liters. Now it's at 11 liters, so we have some breathing room there. Okay. Minus 40 degrees. Let me just change that. No. I guess you have to put up with this then, whatever. But it's too loud. Yeah, this will work for now. So again, what I'm doing here, these ACs, they have an input side, they have an output side, and what I'm doing is I'm connecting the input side to the output side. What is that good for? Well, the input side will be the gas that we want to cool, and the output side will be the gas that is then cooled. And so it would make sense to cool something down, and then this stuff that has been cooled down to feed it back into the thing, until it has cooled down further, if that is a thing. And this is then connected simultaneously to the waste pipe of the next AC.
Hydration critical.
Because this AC, for example, will then cool down this here in a circle. Cool it down, cool it down, cool it down as much as it can. And it has to, because this one will try to cool down the room, and so it will have waste heat, which it will dump into this pipe, which this guy will try to cool down, and so forth, and so forth, and so forth. And here we should have a pipe that is really ultra fucking hot, and that might be so hot that we can drive our furnace with that. So that might actually be a nice side effect. I don't know, I haven't done this yet. Okay. Now we need a passive vent here to vomit out whatever is there. Do we have one lying around, maybe? Lying around? Not so much. Oh, okay, let's make one. Nope, not active. Passive vent. The passive vents also have a variation that is the insulated passive vent, because if you slap a passive vent, for example, oh my god, I just realized it. There's a passive vent here, and there's another one too. I need to make insulated ones. If I can afford them. In other words, I just made a passive vent phone without reason, basically. Because if this is slapped on the wall, then there will not just be the usual airflow here, there will also be the bleeding of thermal energy between the inside and the outside of the station. And obviously we don't want that.
Power critical.
Yeah. Dude, can I stop flying? That would be cool. What? Oh, I still had some cables. Not many though. Yep. How much power do the air conditioners eat? Supposedly they eat 10 watts, but it's only for them being on. When they kick in, they use, I think, easily 1000 watts. So I think these should be on a different circuit or should be using the heavy cables everywhere. But okay, it'll do for now, I think. So now we need to get some gas in there. How do I do that? Tricky. I think I have, there it is. That is the pipe utility gas. So if you look in the hydraulic pipe bender, there will be the pipe utility gas. And this thing has, for example, that. It's just basically a pipe that has eaten too much. It's just a tank, an inline tank that you can put on a pipe network. And a word about pipe networks. Like cable networks, they're not really consisting of individual cables that then simulate the flow of electricity from A to B. This is just a container. So if I add more pipes here, and to the side also, then this will be kind of a tree of things, but ultimately is just one big container with multiple connection points. And yeah, that's kind of what it is. And so if you add this to a pipe network, this will still be the same network. Maybe I should show that on the display here. You can see a pipe network 10227. Do we have another pipe somewhere maybe? Here, of course. Pipe network 10242. This is just some numbers that the game thinks up. Here we have room 1, which was room 5, if you remember last time. This is room 3. Just some internal ID numbers that we are getting to see. So if I would make this pipe much longer and then would even slap an inline tank on this thing, then we would still see wherever we look, even including the inline tank with our tablet, the same number. It's the same one thing. And there's even a big one here, for which we need 2 of these. But I have 5 in my head. That's why this thing's not red. But what I need now is this. This is a container where I can just slap a canister in. And you can see here there's a pipe connection. And that's what I intend to do. I just want to slap a container in there. I realize this can't be placed on the floor because the stupid cable is in the way. But maybe you can just put it vertically here.
Waste tank critical.
Ah, that. Would this work? Yeah, that would work. Bit wasteful to do it like this, but okay. Hey, come on. Ugh. Yeah, now I need to rotate that somehow. Always tricky. Because the rotation keys, they seem to be implemented differently for every device. So when you think this key will rotate it leftward, then no, this is a different device. Have fun. That should work. So where are the pipes? There they are. 5 pipes. This is already closed and proper, but there's no gas yet in there. Then here we have this, which isn't yet completely established. Now it is. Let's connect these then. Yep. 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 And oh, of course. Later I can just remove these things. They don't have their own volume, they're just a tool, you know. I can plop the canister in and then we'll do the trick. And later I remove them again. That doesn't have any effect on the pipe network. It doesn't grow larger or smaller. Now if only I had some canisters with some meaningful stuff in it. Now let's see. There are various gases in the game. Oxygen is very inert, but oxygen is something I need to produce. I can't waste that. I can't throw that around willy-nilly. Then we have carbon dioxide, of which we have exceedingly much. But it will become liquid, and I can't have that. This, though, will happen only no matter how high the pressure at a temperature that is at -8 or so degrees. A temperature which we are unlikely to achieve here, so I could actually use CO2 as the thermal energy pipe gas. That's what I could do. What else gases do we have? Nitrogen, of course, is the ideal candidate, if we would have any, but I don't have any lying around. You can see here, even if the pressure is very high, at -80-ish degrees, -90 degrees, that will become liquid, otherwise it's just gas. Then we have the volatiles. I don't know if they are a possibility here. Let's see. At high pressure... Oh! We could actually use volatiles. I mean, it's a bit risky if the pipe ever ruptures, but why would it do that? The pressure in there will be reasonable. It will be like 2 or 3 megapascals, or when the pipe is really, really hot, maybe it will be 8 megapascals or something. I'm just throwing around some numbers. But it's certainly not going to be 30 or 40 megapascals, let alone 60 when the pipe would burst, and so this mixes with the station atmosphere and might then explode. Set everything on fire. And I mean, -80 degrees is also something I'm not going to see in this station. So volatiles, I have those in abundance, they are an option. Which is ridiculous given the circumstances. Huh. Okay, let's keep looking. Pollutant. Well, this guy of course not, because once the pressure is high enough, it will become liquid. That's what makes it such a great phase change cooling or heating gas. But then we have water, but the ACs cannot work with liquid stuff. Actually, yeah, there is water, gas, and there's also there's steam. Huh? Wait. The liquid water is here among the gases, and the steam, which is not liquid, is down here among the liquids. Come on. Well, obviously this would become liquid at some pressures. We don't want that. And then we have nitrous oxide, which is also quite radical when it comes to phase change diagram. Here we are at minus 20 degrees, and that's where it already freezes. And we can't have that in any pipe. The pipes will just be destroyed. On the right you see the pressure, so we are moving here between like 800 kilopascals and 2000 kilopascals where it will become liquid. And yes, we will have that pressure, so that is also not an option, this gas. So what we could use, there's also hydrogen, but that is not yet implemented, and I don't know what the idea is there. You can also see here some, whatever that is, programmer stuff. Yeah, it's an early access game. Things like these happen. But I'm glad that I paid the money. I paid overall like 70 euros or so for the game plus the DLCs. And I almost feel, but not quite, guilty for getting the game at a discount. So, options are two, but I don't have that to waste. Nitrogen, very cool, but we don't have that. Carbon dioxide and volatiles, both are available in abundance, and they happen to be what we have out there on the planet. I could just use both of them. Well, it seems a bit wild. Let's see. I would opt for volatiles, because they have an even more lenient phase change diagram regarding stuff getting very cold. So, volatiles it is. Hey, another question. There was something about specific heat, right? Latent heat, specific heat. And I believe the higher this is... I mean, that's... Okay, this is 20.4 joules per, I think, kilogram. 20.4 joules. Or per Kelvin? I knew this once, but I've forgotten. But let's look at water. Here we have a specific heat of 72 joules per whatever, kilograms or whatever. This implies, I mean, you can imagine if there's water, then it will be very inert when it comes to heating or cooling. I mean, if I have a pipe full of hot water and then I use some pipe radiators to interchange that thermal energy with the room, what will happen is that the room will get warm, but the water will almost not get cold. That's what I'm saying. There is a high thermal energy inertia here. Here we have 72 joules. Oxygen, 21. Nitrogen, 20, so same basically. Carbon dioxide, 28, a bit more inert, so there's more thick that stuff. And volatiles, 20 again. So that is actually a point of choice where we should think about that. Pollutant is somewhere in between. Do I want this gas to be very heavy when it comes to storing thermal energy? I don't know, actually. Let's say it would be very, very light. So we would touch it, pump some thermal energy in it, and then it would be exchanging that very easily with what? I mean, if I would just take something which cannot store much thermal energy per kilogram or whatever, and just have a higher pressure, that counteracts it, right? It seems to me like the choice is arbitrary. Let's use volatiles. How do I get volatiles now in a canister? We have enough volatiles out there on the planet. I could use this filtration unit which we are having lying around here and just alter its configuration a bit. And then we just slap this dude on here. Then we need an empty canister, which is a challenge at this point in the game. We need to make new ones. Let's make 3, actually. No, 2. Why is my oxygen not ticking down? Because I'm in an evacuated room. So there's basically no cooling that has to really take place. Alrighty, so let's slap this thing here. Get some volatiles filters on there. I actually have one lying around, I realize, because we got this scrubber in our lander, which came with a pollutant filter and a volatiles filter, so we get that stuff out of our atmosphere. We just flip that on and we remove that from the atmosphere. But, well, I can just use the filter over here. And then we need to cable this thing up. That's something I forgot. And maybe I should drink something before we have that as an additional task on our plate. Need more lockers, man. Again. Ah, not enough space. I'm in outer space and I don't have enough of that. I'm out of space. Cereal bar. Okay, so let's turn this thing on. Now we should get some volatiles. Can point here, we are seeing already the pressure, it's very nice if you get that displayed. When we point at the tank otherwise, oh, we don't actually need the thing, that's cool. We don't need the tablet for this. And what is in there though? Pure volatiles, 400 kilopascals. If you don't take care, this will actually pressurize so high, above 8 and 9 megapascals, if it reaches 10, that this thing will explode, which will cost us our station, which realistically will mean death, because we can't rebuild all of that. And we will lose valuable resource. I mean, look here, oxygen canister, nitrogen canister. Not a good thing to lose that stuff to some freak accident. Would be nice then if you could prevent that. Well, we could use a back pressure regulator, a pressure regulator, which would make sure that the pressure on the target side would not exceed a set value. This thing would relentlessly keep pumping, which means that the pipe between all these things would eventually burst. Well, it would be a problem since we're pumping in volatiles. And by the way, let's take a look at this waste pipe here. Here we can also see volatiles. Why is that? Because what's coming out here is not volatiles, but this is just open to the world. And the world is full of volatiles. This is blinking because this thing is pumping. Okay. Now I'm thinking about actually getting the computer set up. And also the programming motherboard. Where is it? Electronic printer mode control. Oh right, I think I have to look for IC10. Okay, if the keyboard is this far to the left. No, this is IC editor motherboard. Yeah, that's the one. So what is the bottle doing? That's gas 3.5. 3. Yes, I'm about to program some stuff. Maybe not right now, but soon enough. Uh, 4.5. No, oh, it's slow. Maybe the higher the pressure, the slower it goes, because pressure differential does play a role when it comes to the efficiency of a filtration unit. If on the input side you have an active vent, then guess what? The output side will be so fast, you will be running for your life. But yeah, anyway, that's... now we need an IC10. This is at the heart of programming, the chip that holds the program. Some gold is needed. The computer is only for programming that. Don't know where I will put this. Here we have the filtration unit. Is there any room left here? No. How is that? A passive vent. A third passive vent. Nice. What's this? kit tables, microwave, and egg carton. So we can have chickens if we wish. There's also another kit computer, but it's for the communications thing for trading, which we will need because we need to eat. To eat, we need to plant some plants that provide food. We don't have those, so we need to trade for that. I believe to have read somewhere that the game is set up so that one of your first traders that you get will actually sell you that stuff. Because there are various kinds of traders. For example, traders that you cannot even get to land on your little station here, because you would need a large hangar, which you then have to flood with the atmosphere of their choice before they will get out of their shuttle, so that you can interact with them, so they can trade. Interaction is simple. You just, they stand there, you click on them, and then you get a menu. Anyway, so now we have a chip here. It doesn't matter where the chip is running, but why not put it there? Because the intention is that I want to turn this thing off when the pressure is high enough. I will have to do multiple runs of this volatiles refilling thing, so I think it's worthwhile. We can do that in the meantime, I think. Oh, this is not an insulated one? God damn it. What's its temperature by now? Minus 200 still. Okay. 7 megapascals. Where is the computer thing? That's 1. Now I'm confused. There it is, yeah. 7.5. So we're setting up the computer, old school stuff. Now the screwdriver. Computer is done. Now we need to give it a motherboard, as it won't do much. We're using the IC editor motherboard. 8-ish megapascals. Now we have to take care. Thankfully, we can just use cables across a pipe. Yeah, I want to go up to 9 and then it's enough. Actually, it is quite enough already, because look at this pipe. This is 10 liters. Okay, let's not calculate, just look at the thing which will tell us the volume of this pipe system. We have here 90 liters, and here in our canister with the volatiles we have 64 liters. So it is 2/3 of the volume. In other words, if I stick that thing in there, we will have 2/3 of the pressure, which is pretty high pressure, if I may say so. But okay, it's a combination of the two pressures. See, now we have almost 4 megapascals of volatiles in there, and that's fine. It's a bit hot, but the AC's purpose is to just deal with that, so not my problem. Now we'll stick this 3.6 megapascal thing in here, and guess what happens? 4 megapascals, because the pressure, the pipe was still at pressure. Things you have to keep in mind. For example, if you have pressurized this very high for a smart canister and this thing is then full, and then you stick in a small canister, of this kind here, that is already kind of full, it will certainly be overfilled, and then you have a bomb in your hand that is counting down that you have to get rid of. You can actually throw it through the window, but that's cheesing, man. Didn't I have wire cutters somewhere? Yep. No. Where are the wire cutters? Okay, you can pump while I search for the wire cutters. Ah, there they are. Had to be one of the places that we just visited. So this thing of course needs power, and it uses 100 watts, so while you're not programming you want to turn that off. You can see here the IC editor user interface, and here you can select which device you want to read code from or write code to. I will go to filtration if I can. For whatever reason I cannot select this now. This doesn't make sense. Not sure what's happening there. 5 megapascals. Aha, now this time it worked, whatever. If I say import now, I will get into this editor the code that is on the chip. And which code is on there? Well, none. There's no code yet. I will just write a short program which will protect us from the explosions. This is not a dumb thing to have, I guess. I will just pause the simulation, so we will not be surprised by, by an exploding canister. So first I will write a label here to which I can then jump. Could also have said jump to jump to line 2, but of course it makes more sense to do this because then it will jump to wherever start is. Then I will write yield here, which means that we don't want to burn the processor. We want to say yeah, we're willing to pause. The real reason is we are doing all of this in the game environment, and the game needs to handle its simulation properly. And this program is taking place within the confines of the simulation. And so when you have, like, I think 128 statements in here with pauses or not, I mean 128 statements, then even if there is no pause in your statements, the program will then force, the game, Stationeers, will force your program to pause for one game tick. And if I say yield here, I'm saying I am willing to pause and actually want to pause right here for one game tick. This means that the counter for 128 instructions, if that is indeed what's happening, I will start over right here. So there will be a pause, yes, but it will be where I want it. So I know what my program flow is, what my timing is. That's why you want the yield there. Now let's load into one of the registers. The load and the save command or other commands usually first want to know where do you want to put that data. For example, here L says load device blah blah blah. Okay, the descriptions are a bit too cryptic for my taste. It wants to say where do you want to load the data, and I say R0 because we have 16 registers, R0 to up to R15, and yes, there are 2 more registers. RA is for return address when you have to jump to a subroutine, and SP is the stack pointer, but let's ignore that. So we have some variables here, and they can only hold numbers, 16 of them, and I'm loading into one of them from DB, which is the device in which the chip is placed, so we can also access, for example, the IC housing, which is the other device in which a chip can be placed. So you can place a chip in an air conditioner or filtration unit and so forth, these atmospheric units, or you can place it in a chip housing, which has 6 screws. So I'm loading from this device into register R0. Now it wants to know the logic type, and I want to know the pressure output, which is the pressure on the output side. Now I have that value in kilopascals here in my R0. Then I will write into R0, so I'm reusing R0, based upon the value of R0. So what I have done here is I have said compare R0 with the value 9000. This is kilopascals because that's the context here. I mean, loading the pressure output is the value, the pressure value in kilopascals. I'm saying if the pressure is less, you see the L here, L and T less than, you can also say greater than or equal, or less than or equal or not equal, and there are some more variations of that, and all of that can be looked up here. So I'm saying if the pressure in R0 is less than 9000, then that is, for me, that's what I want to find out. And let's say the pressure is less than 9000. The canister is not yet that full, or rather the pipe that is connecting to the canister is not yet that pressurized, because that's really what's happening. Then there will be the logic statement 1, because 1 and 0, that's the 2 logic statements there couldn't be. True and false. 1 is true, 0 is false. So now this thing is no longer the pressure that we have, which we no longer need. What we really want to know is the pressure low enough so that we can keep pumping. And now I'll just say write to dB mode R0. What I'm saying is, okay, let's look at the filtration unit in the Stationpedia. Not Stationpedia. Yeah, actually, I'm curious. Does this exist? No. Filtration. Filtration. Haha. Oh, we have to cancel him. Steiner fire. So here we have the logic values. I have to turn on the fan a bit more. Man, 27.6 degrees in here. 0.638 actually. Yeah, well, I have a sensor here that measures down to 1/10 of degree, which I attached to my Raspberry Pi, but I'm doing multiple measurements, and I have a queue of I don't know how many measurements, and I'm always creating the average of these. And so if the temperature is increasing, then I will be able to observe that for every tick of my display update here, even though the change has already happened. I can see the trend is upwards because, you know, that's not bad. Anyway, so we can see here the mode for this device means idle or active. So this thing by default, if you don't tamper with logic and whatever, is active because you can plop this down, build it up, connect some pipes, turn it on, and it will do stuff. So the mode by default is 1. But I'm now saying the mode shall only be 1. Filtration is still selected, good. Up. If the pressure here is below 9,000, you can see it is still pumping, but I will of course have to take care, but I'm pretty sure I did it right, that the pressure, once it reaches 9,000, this thing will just turn off, so we will not blow our station apart. Very powerful, huh? Yeah. Okay, maybe you can already start setting these temperatures. The temperature I want to achieve here is 20 degrees. And let's say 100 degrees. And here 200. I know it's not ideal, I'm not doing it right. But I'm going to be rough with this and just hope that we get somewhere useful. So what's the canister doing? Still pumping. I want to use the labeler to... Oops, what's this? Why have I been holding this in my hands? To rename this guy. That is our CO2 source. Currently a bit abused, but in principle. So now if we look here, we can see CO2 source. That makes it a bit easier. AC room. It's not good really to name these now because... AC1, because maybe I will put up some more, then I have to rename them. But okay. Okay, soon we're gonna have 9 megapascals, and then this device should turn off. This would also even be audible, but we don't have any oxygen, any atmosphere here, so we will not hear it. And now. Oh, it's slowing down. Okay, so this has worked. Temperature 1000 Kelvin. Man, I have 1000 Kelvin volatiles here in the canister at 9 megapascals. Which begs the question, does this thing have some kind of auto ignition? Maybe I should have looked that up earlier. No, it doesn't. No auto ignition. Volatiles is a combustible fuel. It is refined from ice volatiles. Okay, let's take this thing and stick it in. That's what she said. Here we need to check again. I know this is what we did already, but I just want to double check. There's something and here's nothing. So, BEP. Now we have the pressure in here also. And back to business. See, the pressure is lower, now it will start pumping again. Very, very convenient. See the programming language. Let's take a look at this again because you're probably fascinated and want to learn this too and so forth. I mean, programming is, in principle, really not that hard. In principle, but to get good at it and then to write big applications and so forth, that takes decades of experience. Anyway, start, jump start. This is not necessarily how you want to structure your program, but I would say that most Stationeers programs have some kind of loop that just keeps going and going and going. And of course there's more to this than the few things that I did here. But I'm saying do this forever. Load the pressure output and let's look at the filtration unit again. Come on. Here we can see lots of values. We can see whether the thing is powered. We can see open and close, yeah, this little slider there behind which the chip is hidden, you can read whether it's open or whether it's closed, so we can actually use it as an additional switch. What we can also even do is we can write that, so it can be opened and closed. That is something you could do, for example, if you detect that the filters are low, so your program can then just flip that on, open and close the whole time, so that's one thing you can do. And then we have, for example, the pressure on the input side, that is on the right here. On the output side, that is on the left here. And there's pressure output 2, which is here. And then you have the temperature, input, output, and output 2. And you have the ratio, nitrogen, and so forth, for input, for output 2, and such. Yep. 2 more that we have to pressurize. This one isn't yet, okay. And then that one also, and then we can start well, running the ACs and see what happens. I'm actually curious, do we have some gas in here? Yes, we do. 8 megapascals at 730 degrees Celsius, or in other words at 1000 Kelvin, but I need 1200 to be able to make INVAR. By the way, is Constantin similarly hot? No, we only need 1 kilokelvin, so we are just on the edge of that. But I first want to make the INVAR, because it takes a bit, that's more tricky to make. Okay, now, before I... AC room, AC1, AC2, AC3. Before I start the ACs to do something, I need some atmosphere in the room. So once we have this full again, almost, I guess our solar panels are not producing much at this point. They're not pointing to the sky, they're pointing to the side. I guess I should go out and rearrange them. Or we just make a solar that can be pointed at the sun arbitrarily, and then we write a little program that does that automatically based upon a daylight sensor. Also something we can do. Takes about 10-15 minutes maybe. Okay, that has been filled, and now the last one. Yeah, 100 watts. Let's fix the solar panels. Here, 45 watts. Hilarious. We can do better than that. So let's place them again, and this time I don't use the second option, which is angled, but just place them flat on the ground. Make sure that they're yellow, as in they're really connected. And put the glass in, and then we get 250 watts. That's 200 watts more per solar panel, so we're now getting 600 watts more into our station. Actually, I'm thinking about making a second station battery, so we have more reserves. Do we have that kind of material that we can invest? Well, 8 copper and a bit more steel. Well, I'm not too comfortable with wasting steel. But you have seen how important automation is, or actually you have not seen, because you only have seen this thing behave properly. How about if it doesn't? Let's say that we just want this thing to be on. This is for commenting out, so you can comment out entire lines or just the rest of the line. Export. Now our CO2 source will keep pumping and pumping and pumping. Let's save the game, and then we will experience what it's like when we don't protect ourselves from overpressurization. And obviously then I have to reload the game. Which is legit. This is after all an intentional failure. So we're using 500-ish watts in here for the filtration unit, I would assume. Or is... oh, something's being produced. Yeah, of course. And we're getting, from our little power plant here, almost 700 watts. If the wind kicks up, then there's gonna be more. of course. Which it doesn't. Why am I still printing the battery if the station is going to explode very soon? Not even 1 megapascal, so our little mixture of arbitrary gases excreted from the arc furnace box, which is always evacuated so we don't get any overpressurization in the box, or volatiles and oxygen mixing and setting everything on fire and destroying the chutes again, is still good for a long time. And what's in there? Half of it is pollutant, 1/4 is CO2, we have a little fart of O2 in there, so we're actually getting oxygen from our smelting processes, from the gold obviously, and some nitrogen. Oh, there's nitrogen, and volatiles. Oh, what's going on here? Maybe I want to put this away. You can see now it didn't stop at 9,000, it will stop at nothing. Let's just hover there and see what happens. And now, overpressure. Damage. So the damage will count up quicker and quicker because the pressure keeps increasing. Yeah, you see here. And if I get this thing out now, it will still count up because it will rupture. The pressure is just so high. I will not stand next to it because it will just kill me. We just want to see what happens if... Yeah. That. Yeah, because the liquid nitrogen tank also exploded. It's rather cool in here. 50 degrees only. But that's over soon. Everything is on fire. I mean, we don't have that this often, so let's enjoy the show. Yeah. Well, we should take a screenshot of that, huh? Yep. So much oxygen was in there, so it just keeps burning and burning, and then eventually it has burned out, of course. I mean, how do you recover from something like this? It's even still working, hilarious. Okay, some cables have burnt up. That pipe is no longer whole, that makes sense. This guy is also looking so sad. Oh, can someone make a smiley and draw that over the screenshot, please? Lockers are gone. Tanks are gone. Yeah. Okay, pause. Okay, we're back. So this was still producing, and I think this will actually... What the fuck's happening? Yeah, that's one of those bugs that the game has. When you produce something, and then you would usually change the recipe so it doesn't produce many of these, right? And so I did that. But when you then reload, I mean, it's a bit annoying here. Build kit battery. Ah, no, I don't have enough gold for that. Hilarious. That's so funny. Shit, man. And the next thing is a battery charger. I will go to Beacon because it takes a while to print, just in case that happens again. Alright, what about the pressure here? Yeah, I think I changed the program and that would have led to the same outcome again. We don't want that. Bep. It keeps going. Yeah, that's because I have AC3 here selected. instead of this guy. Now it stopped. Yeah. So always important to check what the fuck you're overwriting there. I mean, if there would have been a chip in there, I would have been frustrated. Good thing in the save game, in the XML file, there is the source code is there in clear text. And what you can actually do here in the editor, you can just say copy, which copies the entire source code into your clipboard. And with paste, you overwrite the entire source code with your clipboard. So you can use external editors. So that is generally a good thing to do if you have many things to edit there. But particularly good when you would have to solve a fuck up. Yep. Okay, now we have the stuff in there. What we need now is CO2 in our station. In other words, this dude needs to stop sucking the station dry. Do you have any atmosphere in here? Oh yes, we still have atmosphere in here. Very low, almost nothing. Some volatile, some pollutant. I will just ignore that.
Down-tempo techno ambient chill. Groove salad on Soma FM.
And instead stuff the volatiles filter back. Now that's a little problem. I have this canister here with volatiles that I don't need. I cannot really empty this thing because I don't have a canister holder with a pump that would pump that out. Then in principle I would have to do this, and maybe I should. I actually would keep it here for realism. I could just toss it away. And here we have this pipe. There's still volatiles in there. What do I do with that? I mean, right? That's a problem. Ah, wait. Here. 9 megapascals. So lots of stuff is in there. 11 moles. Should I unleash her into the room? Not a good thing to do. I was hoping for better music. So, how can I get rid of this? I could remove this gas tank storage and then add a pump that removes this stuff and moves it to a different pipe and so forth. And maybe I should do that to demonstrate a few things. But maybe I should also just cheat right now, because if you remove this pipe, then sadly this will not unleash the pipe's content in the atmosphere. It will just annihilate the gas that was in there. What's with the music today? Okay, now we're prepared. What? Oh, it's still on. Oopsie. Ha 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 ha. So now nothing's in there. Let's get the CO2 filter started again. Didn't I have a second one? I did. This one goes back to the scrubber, which we can then start using, because there's still some crap in the air that we don't want. So let's turn this on. You can see here how it is already decreasing the ratio volatiles and the ratio pollutant, because these are just the two filters this guy has. So let's turn this thing on and oh. Okay, not a big problem. I thought where do I put the passive vent now? You cannot place a passive vent in a cable, it doesn't work. But I don't have to. Where's the wrench? Here it is. And start pumping. So what's happening now is we're getting in here a temperature of 700 degrees, 11 pascals, 13 pascals, more pascals. That's very few pascals. We're talking kilopascals that we have to achieve. So this is nothing what we have in here. Let's let this thing keep pumping. We're getting only CO2. That was the goal. But it's way too hot. So do the ACs help with that? The big moment. Start, 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 and start. Temperature 719. I mean, we're still kind of... oh, right. There's nothing happening here. I can't say that something's happening. But most of the pressure is just being put into that pipe here. 719 degrees. Ah, 718 degrees. Okay, something seems to be moving. Not as much as I'd hoped, but well, 700 degrees, and I believe the maximum temperature differential these guys can really work with is 50 degrees. We would need like 15 of these guys or so. But I mean, let's see. So we're currently breathing probably a bit faster now than before, because this guy has to cool us now. Since I don't have any oxygen to waste, let's stop this here and investigate what's going on with the thingy here. Here we have 640. Okay, look, the temperature of this waste pipe here is decreasing. Here, also decreasing. Here it's rather high still, but is it decreasing is the question. Yes, it is. So what's happening to our furnace gas? That would be the question. Well, I'm not sure. Too bad the tablet doesn't show you the value in Kelvin also. But in principle, the temperature here should be increasing. Theoretically. Does this have a display? Yes, it has. Heat exchange rate, 583 joules per tick. Maybe the amount of heat that we can pump into this thing by these means is not high enough compared to the amount of bleeding that this guy has. I mean, it's convecting 250 joules in the atmosphere, and we're getting 500 joules into this pipe. That doesn't sound like a success story here. But this is only a side effect. The actual goal is to cool down the station. And how are we looking at? 740, 715, 665, 579. Way too much. Oops. Not what I wanted. I heard that some kind of pyramid scheme is supposedly successful, like when you have 2 or 3 of these next to each other for the very high stage, and then the next stage one less, which is less hot than also, and so forth. I don't know if that makes sense. I just know that slapping on more ACs should certainly get the problem solved, and so that's what I'm gonna gun for. 718 degrees in here. And it's not actually decreasing, is it? Yeah, it looks like over here we would have to implement some kind of airlock, I guess. Not sure. Should I build another airlock right here? And this then is an automatic door? I'm not sure. We need to get it cooler in here. Of course, what I could do is I could turn this dude open. See, now we're getting... oh wait, that's water. That was dumb. Here, right, the green stuff. This guy is so cold. Now we have a temperature here of minus 20 degrees or something. At least directly here where we have released that. But, I mean, you have to remember, the station doesn't have any pressure yet. Once we have, like, is this still pumping? Where's all that pressure coming from? This is closed. Closed? Yeah, you just maybe saw these squiggly lines. It means that the gas is in the process of evaporating. And if there's some raindrops, it means it's condensating. 90 degrees in here. Huh. So I think the ACs as they currently are super ineffective, but they are doing something. Here we have 400 degrees, you have 600 degrees. Overall what we need is we need more ACs. But I just don't know if that is good, if our power network is good enough for that. If we need heavy cables here, I don't know. Hey, we can look at the power consumption that we have here. Go away. Okay, we are almost 2000 watts power consumption. Well, I think we can do with with... Let's put up 3 more of these guys. If we can afford it. Let me guess, this is one of those copyright thingies again that I have to mute later. Ah shit, fuck off. Okay, go back to generic music then.
Power critical.
Uh-huh. Oxygen. If you're blowing through a few thousand watts, doesn't this imply that we need to produce that amount of watts also? If you want to keep this running? I mean, during the night we won't have so much reason to cool, because the influx of thermal energy will be much lower, but still, we should be ready for that. In other words, I need to go mining, while this guy keeps spitting out... Okay, we have 2. Let's see how much we can do with 2. Okay, let's do another thing first. Here we have a little display. It tells us the thing is currently active. Operation temperature efficiency is 37 degrees, so 37%. What's happening here? 11 megapascals. How is there any water in there? I mean, this thing has not been on since I had accidentally unleashed some water into the air. I'm very sure of that. This thing was not on. How is it in the pipe? I don't get it, man. You can see that the pressure, the stress is increasing and increasing. I don't get why. Oh, that's the output side? Oh, I done goofed. This is the input side, man. Woohoo! Yeah, that explains several things. For example, the 0 efficiency in regards to cooling. Looking forward to seeing the opposite, the flip side of this. Literally. Ah, fuck off. No wonder it wasn't digesting anything. Come on. So, is something happening or isn't it? Okay, the pressure in this pipe is certainly increasing, so we have to stop this guy. And now it should decrease again, because the AC is hypothetically doing stuff. Oh, it's not, because it's not started. Oopsie. Oh, now it's empty. Okay. Oh, it's empty now. Not sure if it's cooling. Well, and this is where this comes in. Mode active, process, input 25 modes, operation temperature efficiency 40%. So the temperature efficiency is okay-ish. The operational temperature efficiency, I guess that's where this thing is standing. I'm not sure even really what that means. But the temperature differential efficiency is 0%. It's just too hot. The waste pipe is too hot. It cannot pump anything in there. But if you look at the waste pipe here, we have 400 degrees, 500 degrees, 600 degrees, and 700 degrees. In other words, if we have a longer row of these dudes, then we will have some cooling ultimately in the room, because then the pipes would get colder and colder. Okay, let's stop this, for it's a futile effort in this current form. And actually think about getting some power source in here. I wonder. Well, I made another battery. At least let's put this up then. 2 steel sheets, please. Oh, we need steel for that. Who would have thunk that? Maybe I should now turn this into an actual airlock. Okay. So gas sensor needs to be selected. The glass door is the exterior door. This is a composite door. Active vent exterior. Is that this one? No. This one. So I selected the wrong one. Plim, plum, plum, done. The disc is no longer needed right now. So I can put it somewhere, and up there we happen to have some slots that are not needed. They are legacy. So yeah. Now turn this off, we no longer need it, and cycle the airlock. So, where to place the battery? We can place it right next to the other one. Not the dumbest idea. We can even place it so close that the switch is no longer operational, but then we can just use some chips, a batch writer, or even the programming, which will be only one line, and really, yes, only one line of code that would turn all of the batteries on if we had their logic connected, which we have not. So I would just put them like this and be done with it. So whatever dumb decisions I make in the future, at least I will have some kind of buffer here. Oh, wait. This cable would have to go here now. Cooling on the moon is a pretty cool thing to do, because on the moon you have a vacuum on the outside, and all you need to do is pump your station's atmosphere through a pipe on the outside, a pipe that has some radiators. This will then radiate away into the vacuum of space, and that is very powerful cooling. You have to make sure though, since it's really that radically powerful, that you don't leave some lingering atmosphere in the pipes, else the pipes will eventually burst, because it would indeed cool down further and further to 0 Kelvin. Let's connect this. Do I have some heavies? I have. Not enough, I think. What is this? Oh, I do have enough. Good. So both of these are now power sources, and they're both being charged. So we need to mine some more. The ACs are turned off. Maybe I want to get rid of all the stuff I'm carrying first. Oh, the belt is empty. Another canister maybe? Oh, there's another canister, okay. Yeah, I'm not sure if I will evacuate the station again, because as long as my cooling isn't up and running, I'm not sure of anything. This is really the key problem. Oh, the battery has been sucked dry by the air scrubber. Do we still have something in the air that we don't want there? Some water, but otherwise... Whoa, man, look at this. This is how full this thing is already. Not good. And this wastes electricity. For no good reason. Is this thing off? It is. Close. Yeah, we need more resources so we can make more wind turbines, so we have a good power supply. And we need to set up more of these guys. In other words, this supposed last step is not the last step at all. We need at least 2 more, at least. Make it 3, I would say. Very tedious, huh? But that's what it is. But we're on Vulcan. Things are extreme here. We could also use phase change cooling, I guess.
Filter low.
But I am not proficient enough to set that up. I mean, I know what's happening there, but to come up with an efficient engineering solution and to put that into practice, that's a different story from understanding the concept. Wonder if I have enough steel for all these insulated pipes that I need. Okay. Well, I still have some steel, but would it be enough? I don't know. Maybe I have to make more steel. How late is it? Stupid question, but I mean, I can still make more steel, right? Or what's going on? Do I have some steel, maybe? Materials for making steel. Silver. No, that is not for steel making. I have coal, that's good. I need iron then. Iron and gold. Yeah, the usual stuff. I need to go mining. Okay. Let's do some tool maintenance. Oh, 38. Save and go. Yeah, now we can just click. Man, I forgot to set up the mission timer. Who needs it? Maybe next time. I really have to do something about the temperature in here, man. Way too high. Help? Hopefully that doesn't blow in the microphone too much. As I could have turned up the big fan anyway. So, I mean, I have done these cooling chains successfully on Vulcan twice. This is a thing, so yeah. Ultimately, I mean, one of the most interesting things you can produce on Vulcan is cooling. So, I mean, to have some large power plant, this is just me talking out of my not very sophisticated engineer ass. If you would have... Shut up. If you would have a large power plant, then we could just have a huge cooling setup with like 40 ACs or whatever, and have a high throughput, and this would then be the source of all the coolant. We would then keep producing cool gas, very, very cold gas, at like minus 80 degrees or something. And then we could use that to cool whatever we need. So we would just create cold. Cold is something we would manufacture, and then we would use that whenever we need. That's actually the way to go. For example, we have this nitrogen canister there, this nitrogen tank, which I would like to use. The problem is when it's used up. I don't have any more, and I don't know how long that would hold. I could just use a portables connector on the ground. That's just a platform like what we already saw for the gas generator, where you connect it to the ground. That is no longer just for charging batteries, but it can also be used for just piping electricity right into the station. In the same way, we could just connect this nitrogen canister with a portables connector, and then we could just unleash that directly into a station, and we could control this unleashing with logic and with a gas sensor, with a temperature sensor, which is what the gas sensor is in effect. So we would constantly have a very elegant, very quiet, small little cooling solution that would kick in whenever we need it. Problem is, at some point that cold stuff would have been used up. So one of the most interesting things you can do here on Vulcan, or on Venus also, is to create, to engineer something that produces very cold gas. And then you can distribute that in tanks to your various stations, station sections or whatever, and utilize that. But we're not there yet, we're still at the very beginning, man. Should find some more gold. Yeah, IC10 programming is very interesting. You can do cool things there. For example, you can make a manual airlock. Okay, it's not manual, then it's still automatic, but it's not using these consoles, it's using your own code, and they are really the fastest. You know, you can basically just walk straight through almost without having to slow your stride. That is how fast they are. I did multiple times. I also have a video up as part of my atmospherics tutorial, or no, as part of my programming tutorial series with the short videos. These videos, though, are a bit longer, the ones about airlocks. Okay, let's see what we can do with this stuff. Hey, we have all these nice battery chargers here, huh? Maybe I want to put up one of these here. Is it in the wall? Or does it go up to the wall? It is in the wall, shit. Ugh.
Power low.
This guy can stay, but we will no longer utilize it. Let's smelt some stuff here. Iron, copper. Oh, it's still busy? Why is it not doing anything? Excuse me? Oh, this could be related to the game being loaded, I would imagine. Annoyance. Maybe I should just write the short code necessary to make that these chips superfluous, huh? Activate. It's really just short code, I mean... Do we have access here to the arc furnace? I don't know. Is the arc furnace on this logic network? Yep, yes, it is. So, let's do that then. This thing has to stay on though, because this is the one that runs the code. And so that's the problem. I guess I need another IC10 then. Crap. Let's make one. And the housing too. This needs steel and solder. Steel. I remember I wanted to make steel. Well, we have the resources for that now. Let's make a shit ton of steel, huh? If the sun is still high enough. One, two, three. 1, 2, 3. And then we need 2 stacks of coal. Oh, it's still on? What the fuck? I thought I turned this off. Temperature 700 Celsius. Which means we have over 900k, which is what we need for steel. Pressure in there is relatively high, so let's toss in all the ingredients for one batch of steel and see what happens. Temperature
Waste tank critical.
is falling.
Temperature high. Temperature critical.
Yeah, way too cold, but it should be heating up because of the environmental temperature. And maybe also because of our nice pipe here, which should be very, very hot still. 500 Celsius. Yeah, the temperature is slightly... Is it? 526, and here 520. It's the same temperature. Huh. If only the ACs were a bit more balanced, if we had more of the ACs set up already. Yeah, I'm letting in the poisonous stuff, lots of it. And look at this, we have 6 kilopascals in here and most of it is volatiles. Not good. I need to set up an airlock here, this cannot continue. Crap. Oh man, so many things still to build. Before we can even start making plants, it's ridiculous, man. So, IC housing, for that we need steel. Okay, I'll put this in. And an IC tin. Then I wanted to make some kit atmospherics. Yeah, okay. Air conditioner. Do we have another one? Where shall we place the housing? Maybe next to the PC, that kind of would make sense. Oh, up here? There's no cable. Oh, this would be even better. Needs less cable. Ah, front. Upside down. Not that it's important. This thing consumes 50 watts when it's running. Not the chip, the housing. Did I interrupt this? Apparently. My cable actions did that. Stupid. Yeah, the sun is going down a bit. Maybe I should evacuate the station again, because what I have in here is just garbage. I mean, any efforts that we made so far to get something meaningful in here, they're just voided. Which is pretty annoying, I must admit. Okay, let's do this arc furnace thing. IC housing. Import. Oh, there's nothing in there. Who would have thunk that? Define. Hash. No. Arc. So, I'm loading from the arc furnaces that exist into register R0. The logic type, from the slots, slot index 0, whether it's occupied. And then I'm writing into all the arc furnaces that exist on, and that should be it. That should replace the 3 chips, all of them. And also should make sure that this will survive any and all interruptions, like saving loading or whatever may have been the reason. Should I explain the source code? Yes, this is a beginner tutorial. So we already know the concept of the main loop. What I'm doing here is I'm not loading something directly from the device base, as in where the chip is placed. There's also D0, D1, D3 and so forth, which would be loading whatever is assigned to the screws. You know, you can just walk up to these screws of the housing, including the 2 screws in the filtration unit, for example, and use the screwdriver and select a device with this. And in this way, then I would read from that device. Load into R0 from screw number 5, whether this device is on, for example. That's what you can do. But you can also use something more general. You can say load batch, as in all devices. If I load from all devices into register R0, now I have to say which device type do you want to. Then I can say arc furnace. And if you look here, we have the kit arc furnace, and this is one of those moments when you have to really distinguish. The kit is not relevant here, we need the built arc furnace in the world. And then we have this number here. This number defines the type. This is the number that we need in our source code. But nice enough, we don't have to actually write down this number. We can just take the name and use the hash function. Then we get this number. And that's what I did. Structure arc furnace. So I'm loading from all... I'm loading here from all the arc furnaces that are connected to the current cable network into register R0 the value, for example, if it's on. And since I'm loading batch, I explained that already in the previous episode regarding all the logic chips, since it's multiple possible values, I have to tell the program what it is supposed to do with these multiple potential values. I can say maximum or minimum, or I can say average, or I can say sum. Here I'm doing the same, except I'm not loading a batch from all of them. I'm loading batch slot, and we have a slot reader, a chip on the ground there, which is connected directly to the arc furnace, screw-wise, I mean. But since I don't want to use the screw approach, I'm using the batch approach here, and so is load batch slot. I know it's a bit fast, but I have some extra programming tutorials up which explain that very thoroughly. I want to basically move on from this here. So I'm loading batch slot, as in I'm loading from all this device from a certain slot. Which slot? This one, the first one, slot 0, into register R0, whether that slot is occupied. And if there are multiple such values, just add them up. 1, 2, 3, let's add them up. I know there's only one arc furnace, so I don't care. I could also just say maximum. Let's do this then, whatever. And then I'm saying write to the arc furnaces, all of them that are on the current cable network, they shall be on. I mean their on value shall be whatever R0 says. And when the slot is occupied, there will be 1. And then the device will be on and will also be activated. This means that when there's nothing in the slot, it will even turn itself off, so we're saving a little bit of electricity. So, housing, export, run. And now I need to get rid of these chips because they are superfluous now. Saves us some real estate and tons of cables. Getting some cables back even. And immediately it's on and it's smelting. All is well. Orderly. Nice. And is it smelting the rest, or is there nothing more in there? Why is this thing still on? Honestly, it should be off now. Something's not working right. Oh, I guess the problem is that this is no longer connected to the rest. Yeah, okay, that's the problem. Little mistake there, there had to be a connection. Because now, for example, these guys don't have power. They're only connected to the logic of the arc furnace, which is obviously not a power thing. That's why the arc furnace is not doing what it's supposed to. And now it's going. Convenient, this programming stuff, huh? You just express your will and the computer will do it. That's the way. Pipes. Oh, that was the last pipes from that stack. Can we make another filtration unit? Atmosphere... I mean filtration, I mean... you know what I mean. Iron gold, I guess? Oh, that was copper that was missing. Dude. Oh, it's full? Oh. But now we will no longer have the problem that this guy will somehow stop smelting. It will just keep going, and keep going, relentlessly. Maybe the furnace is now hot enough. Quite the cooling system that will be. So how are we looking? 845. That's not hot enough, man. What do I have to do to get this hotter? Wait is what I have to do. I'm not a fan of that. I guess the problem really is that the gas in there is just too massive. There's too much gas. We can pump out some of it. Set inward? No, we want set outward. Ah, now the pressure is decreasing, which means that if out here it is indeed hotter than in there. In there we have 574 degrees, out here we have 640 degrees, but it's also decreasing, or is it? No, it's not really. It's because I'm pumping out cold gas. This should now be more responsive to the environmental temperature and heat up more quickly. At some point, when it's must take care not to pump it completely empty. Also, a job for automatism, basically. I could use a back pressure regulator here. I could say, hey, I set a back pressure of... Why am I not doing this then? Because it's a one-way street, while this thing can pump also into it, this thing, which was the idea. But I can use a pipe cowl here and a back pressure regulator. Yep, I could do that. God damn it. Yeah, this is one of those gases in the furnace which are combustible. But I really don't understand why it's not coming out the whole time. Why is it coming out like slices on a cake or something, like layers? That's weird, man.
Hydration critical.
Anyway, temperature. Well, oh come on, this thing's broken now. Yes, destroyed. I get that. I want to get rid of it. Oh, angle grinder. Okay, we need a new active vent, and we need a back pressure regulator for next time. I have an extra kit atmospherics here, actually. Ha 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 ha. So we go to the pipe bender and we say I would like something about regulator, and then we get the liquid or the gas pressure regulator. That's a kit with a back pressure regulator and a pressure regulator and two other things, I believe. I think it's the purge valve and the pressurant valve. Let's look at this. Here, the pressure regulator, which makes sure that on the target side, you can see the arrows there, right? There will be a certain pressure. I mean, if the pressure on the target side is higher, then that will stay that way. If it's lower though, and on the input side we have some gas, I think even if it's less gas, then it will make sure that on the output side we will have the desired pressure. The back pressure regulator does the opposite. On the input side we have a certain pressure, and if the pressure is higher than what has been set, then the guy will pump that over. I guess even if the pressure on the output side is higher, so it's kind of a pump. Then we have the pressurant valve. You can see from the symbols here that would pump gas into a liquid pipe, which makes sense because liquid pipes are just pipes. They can take liquid or gas. Their maximum pressure though is not 60 megapascals, it's 6 megapascals, much less. So you can do much less with these things. On the other hand, they're much more flexible. Yeah. So then we have the purge valve, which is the opposite, which pumps gases from the liquid pipe to the gas pipe. Very interesting thing, a liquid pipe always has to have some pressure, if there's liquid in there, I mean. So if you would remove all the gases, then immediately some of the liquid that's still in there would boil off, which cools it down, because that's what happens when the stuff evaporates, so that we have some pressure again. So if you keep doing that, you would cool down the pipe ridiculously. This would of course then produce well, maybe I should actually try to employ that at some point. Temperature is... yeah, 14 more kelvins, and then we can flip the lever and we get some badge of steel. I forgot the pipe cowl. Why should I not make a mistake this time? No! This thing eats 100 watts. This thing also. That is... Wait, what did I just place a pressure regulator? Dumbass.
Power critical.
We need the back pressure regulator because I want to make sure that the pressure in there doesn't exceed a certain level.
Hunger caution.
Okay, look at that. I mean, it looks like we can just stay here and watch and then the button will go green. When you see this here, jump to 900, the button will not immediately go green. Why? Because what we're looking at is of course a rounded value. The temperature is for like 10 decimal places or something. And so at some point it will round up to 900k. But round up is not enough for the actual mixture to be okayed. So but instantly after it should go green. That's how it should look, if this is properly implemented. Dude, we're waiting for this shit. Make it happen. Wonder if this would be faster if we would just pump in some hot atmosphere from out here. Theoretically it would be. Not now though. Wanna observe this. 8, 9, 9. Come on. Since it's going so slow, we should be able to observe said rounding effect rather clearly. Aha, okay, it's not yet green, but... Now. Hello. Logic. I wonder if I should risk that again, and the answer is yep. What kind of nuclear bomb do we have in there? Where is my tablet? Where did I put the fucking tablet, man? Why do I not have my tablet on me? This did hopefully not burn up again, or did it? What's happening? I don't understand. We have a pressure here of 70... Why do we have 70 kilopascals pressure here? Please tell me that was fast enough. Oh, the active vent is currently on fire. Maybe it helps if I just deconstruct that. Which is of course cheating. Hey, what? What? Still on fire? Where's that fire coming from? How hot is this? Not hot enough.
Temperature high.
Oh, I have no more
Critical.
power in my
Oxygen low.
spacesuit.
Temperature high.
Now let's pump some gas in there and see if that actually increases the temperature. It does. Aha. Radically even so. And we have a green light for steel. Hello. Problem is just this explosive stuff that came out there. Damn it. Anyway, we have steel. So where's the tablet? Did I destroy that? Was that burned up? Did someone witness that? Man, what's happening? What am I doing? Often it's accidentally put in a locker somewhere. Or maybe up in front here when I did some retooling. I guess it burned up again. Did I just lose a second tablet? Really? God damn it. Vulcan is a beast. So yeah, this is my beginner tutorial for Vulcan. For you to learn Stationeers. I guess you can learn a lot of things here. Particularly you don't want to play Vulcan as a beginner. I guess I lost it. The tablet is really burnt up. God damn it. 2 tablets. Don't tell anyone. Good thing there's no video evidence. Yeah, let's make a large battery again to replace yet another thing, which will then free up a small battery. I just don't know which one. It's rather arbitrary. You know what? I'm just gonna put that large battery right in the sky. Yep. Once I have remembered to push the fucking power button. Atmos.
Waste tank caution.
Again. So for the umpteenth time we have a tablet here. This guy is still smelting happily. Okay, let's try to get that room cooler. It's ridiculous what I'm doing here, man. I'm so looking forward to having a working cooling solution in here. Man. Good thing I didn't yet unleash my nicely stored stuff there. That would have been a waste. Something to drink, I guess. This is such a tedious setup to make, but
Air tank low.
it should get the job done. Like it did in the past. I mean, I have done this before. And we also saw the signs that it should be working based upon
Air tank critical.
the waste pipes having different temperatures. That should work. Can't believe you have some extra steel here, man. Insulated pipes, please. Now that we have given these guys pressure, I can remove them again. Because they are no longer needed. So you can add them right here, indicating where we have to work next. That's the spirit. No, not here. That's the output thing. So hot in here. What? Dude, are you sure you're not supposed to swallow that? I should evacuate the room. And I need an airlock over there. So let's make a console. All that stuff again. Iron. Oh. That's not right. Yes, I know that there were more configurations already where it would have worked. This is not me showing you, hey, you have to do it like this or else. I'm doing it wrong. But, I mean, okay. Ultimately getting the job done, I guess. I hope. That's not enough pipes. Where shall the power come from? Still building base infrastructure. At some point, everything is gonna be smooth. And then we can start cleaning up and improving and expanding. Trading for food.
Hydration critical.
Okay, that seems to be done now. Now to fill it with volatile gas that we have to get first. From guess where? Huh. So we will take... Oh. Hey, what? Where's the CO2 thing? Oh, it's... Oh, okay, there's a scroll bar. None of that. CO2 source. Import. That is an already established volatile canister, I think. It is. How full is this thing? 99%, not 100%. Where is the volatiles filter? So ridiculous. Man, the station is too small. Need to make it bigger. Okay, that's the code we have on there. 9,000 is the goal. Alright, I think we can let this run. Filling it up. With what? Pure volatiles, nothing else. Okay. I don't know if this will explode. Let's just save. It shouldn't explode. Okay, so that's this. Now let's continue with the airlock. I have the advanced airlock chip and the gas sensor. Need some glass sheet. Other building materials. Not sure exactly what I need. I definitely need 2 doors. Or 1 door, because one I will dismantle. Copper, Something more that I can smelt while we're at it? Because this thing seems oddly idle. Oh, it's even turned off. Aha. Now let's see what happens. Will it actually turn on? Yep, perfection. I mean, these 3.5 lines of code. Much better than the logic thingies. Whoop. How are things looking over here? Filling and filling. Music change. We need an area power controller. I think we have one lying around still, don't we? Or did we use all of them up? No, I used all of them up. One is here, the other is over there. Do I need this one even? I mean, why would I have an area power controller here? For the airlock? Yeah, that makes sense. But this one? For what? Let's remove it. Regarding power networks, I already told you that that cables can burn out. There's a nice way to circumvent that. You can... Okay, one less nice way is you can just place fuses. A fuse will burn out when a cable would otherwise have burned out in a different place. So that's a good thing. You can just wrap that around the cables, basically. And then there's also... They're on the wrong side. What the fuck am I doing? There's also transformers, which are the real deal. They are meant to make sure that only a certain amount of power can possibly be consumed. So if you even if you have a station battery, which can basically consume infinitely much, the transformer that you switch before it, you can set it, for example, to 5,000 watts, and then the station battery cannot consume more than that. So you could even use a coal generator on the input side, and on the output side only then use thin cables. Would be a complete waste, of course, but nothing would blow up, you know? And that's the idea. That's what I'm saying. Transformers. some glass? Oh. There it is. In the other hand... I'm missing a tool. Ah, there it is. Cables, cables, cables. I will not have enough of these for that. Should it be a glass door or should it be... Well, I want to know where I'm going, so it shall be a composite door, which tells me where I'm going. And then when this is closed, I will change out this door against another. But first I want to put up the electricity supply and so forth.
Waste tank critical.
Ah.
Temperature high.
Yeah. Maybe I should evacuate the station using this vent up here, but first I want to complete the airlock so I can make sure the station stays stable. So we need 2 active vents. We happen to have these. Oh, no, only 1? What the fuck? Didn't I have an active vent lying around over here, which I of course need still. I'm not saying I don't need it. This is the input side, yes?
Hunger critical.
Do I not have any more cables? Yein. I mean, yes and no. Meanwhile, almost... how many gigabytes? 54 gigabyte video is still uploading. Which is the first episode of this. That takes so long a time. Okay, now a passive vent, if we still have one lying around, we do. Right, I didn't even take care of that. Hey look, we are punching out our teeth with every step. Bonk. Bonk. 9 megapascals. Now I check to be sure. This is filled. And this is not filled. Interesting, there's only 2 megapascals now, because the temperature is at 396 degrees. This decreases the pressure, of course.
Filter low.
Yeah. Is the furnace done? It is. Can't believe I made steel without needing the trader to get some oxygen, man. Not bad. First time I do this. Let's remove this as indicator that this is done. Well, soon we're gonna have all of these guys running, but oh right, I need to make some more power supplies. I need to make some upright wind turbines. Do we have the resources for that? We can make 3 regarding iron, 2 regarding gold, and 1 regarding copper. Well, copper's in the making, so that should be a thing, yeah. Then we also need some frames. I could make steel frames now to continue there, but I have some kind of mental block. Whenever I start something with iron blocks, I have to continue with that. I mean, it's not a force, it's just my decision system is saying, yeah, let's continue with that, period. if I would feel uncomfortable with that. It's just that I know that it's not very economic to do it. That's what's going on. Yeah, what we can do, we can put a console here which can show us what is currently being smelted, and we can put a little progress bar display here that will show us how far the current smelt is. Yep, that is a thing. But I think that kind of luxuries are not yet part of what we should be doing. Huh. Well, let's already put one up. Do I have some cables left? I don't think so. Yes, I do. Once again. But not enough. No more copper. Okay, that's kind of the problem here. So, how are we looking in regards to drinking? I have enough water, and I can also set things up so that I can...
Power low.
so that I can drink stuff. But, so that I can get it into my water bottles. But then I will have something exposed to the atmosphere here, and it will get hotter, and then my water is basically gone because I can no longer use it because it's too hot. That's something I don't want to risk. Okay, that's not actually the case, but I would just waste some water, definitely. So I first want to get the cooling solution. That's what's going on here. And the food, yes, yes, alright. Oh, a copper is done. Nice. Make some cables, please, because I want to connect this turbine. 5 should be enough. And then make another upright. Then we would have to put in some gold as a reserve. 4 grams? Nope, that's not enough. 10? Neither. How are we looking? That's enough. Yeah, like I said, there will be storms. That starts on day 7 after your landing. Might actually not be on day 7 because a random generator thing starts then. But in principle, then you would get storms, and storms mean, for example, that your wind turbines will have a much larger output, but on the other hand, you will basically only see a few meters. And the solar panels, they will get damaged by that. There are solar panels that are hardened, to whom that cannot happen. Did I leave the wind turbine inside? Come on! Or you can just put up a solar panel indoors. If there are glass walls, and that should work. Okay, let's put up 2 for now. The rest is printing. 2 batteries. More gas. Volatiles. And one last time. Oh, this can be off. 100 watts saved. Still producing? No, it stopped. Why? The iron is missing. Of all the things. Let's make some cables first. Yeah, the station should be expanded further to the width. And maybe I should then indeed use steel frames, even though it grinds my gears to have these different floors then. But okay. So let's make some steel frames. We have enough steel, don't we? I want the big one. Where's the big one? Here it is. Steel frames. Kick it. See, only 2 grams. Yeah, what's our arrow doing? It doesn't construct itself, does it? We need an active vent up here that pumps back into the station. And one up here that pumps to the other side. So we need 2 insulated passive vents. Oh, by the way, the pipes that I have up there, they are also leaking thermal energy. That is a thing, yep. So we can actually insulate pipes after the fact. I believe I saw that lying around here somewhere. I mean, like, we don't have to remove the pipe. We can, of course. I mean, who cares about these pipes up there? Just wanted to show you that. Where is that stuff? Ah, there it is. Adhesive insulation. Yeah, you can print that also. And you apply that with a wrench and the insulation. But it's important that you... Okay, let's just look at this. Up there is the pipe. I'm looking at the pipe now with my insulation hand, and it says you require the wrench in the right hand, or in the other hand, that's what it means. Now if I'm doing this, I would deconstruct the pipe. It's not what I want. This upgrades the pipe. There's no such thing here. Okay. Two more. Yeah. How wide is the station again? I mean, how long? 1, 2, 3, 4, 5, 6, 7. 7. So let's expand it by 4 blocks in that direction, I would say. Which means 28 frames. Wait, what am I saying? 7 times 4. Yep, 28. Okay. Looking forward to testing this AC system with the new capabilities. I wonder what our power will do, or if any of the power lines will burn out. So we want to achieve 20 degrees. Here I'm willing to go to 100. Maybe that's not ideal, but whatever. Here we'll go to 200. No! 300. Finally, I'm getting a bit cooler. Fans are such great things. I'm a fan of those. I don't know if 600 makes sense. Maybe it doesn't. What temperature... Well, that's the thing. Once this whole system would kick in, it will certainly produce much higher temperatures over here in the waste pipe. Oh, it's already running. When did this turn on, man? Temperature 500 degrees and falling. 600 degrees ish and falling. And see, all of them are falling now. What power are we consuming here? What's happening? In is coming, the 100 watts way too little. We're consuming 3000 watts, so that's a problem. $30, alright. Plus 3. That's only 3, man. I wanted 4. Not enough copper? You don't say. Okay, I have to continue with the airlock. These guys are now robbing us of all our electricity in the batteries. So I should actually print the coal generator. For that though, I need to make sure that the cables that are going into the batteries are all of the heavy kind, else there will be burnout because of the 20 kilowatts that will be blasted through that. Coal power is actually very, very viable because it outputs so much energy. Can I make this thing? No, it's here. We need the solid fuel generator. This takes iron that I don't currently have in there. Something more to smelt. Nope, we would have to go mining again. So currently everything is under load. Just too late. Solid generator. $18 cables should be enough. Let's prepare the next food thing. Food and drink. And once we have more room... Hey, could I put another... Hey, you know what? I could stick these a bit closer to each other and then another locker there. Let's put up another locker right away, man. For that, I need iron that I don't have. It's ridiculous. No, not that. Then maybe in here. 38. Nothing? Okay. And after that we need to create these heavy cables. We have 6 gold in there, that's not enough. Lots of gold, some copper, yeah, that's good, that's good. Where will I place this? And how would I access it? Could use an area power controller so I can separate that. Let's make an APC also. We can even make it, yeah, because we have lots of solder. The long night will soon begin again. Do I have everything? I think so. So here's a solid fuel generator. On the right side we toss in the coal, and the left side we get out the power. all of these cables I will leave weak. Wait, I have to check some. So we have the wind turbines. These are the large ones. During a storm they output 10,000 watts. But during when it's not stormy, then up to 500 watts. Now the upright wind turbines during a storm 800 watts, and otherwise 200 watts. So 200 to 500 is not such a large step. 800 to 10,000 is a large step. So we can tell that the tall wind turbines purposes is basically to have some battery park. They are larger station batteries even than the ones you have already seen. And to live from storm to storm in a way. And they have a large footprint. So you need lots of resources to make them happen and lots of space to place them. The upright wind turbines are otherwise a way to go. Now let's see, they output 200 watts. If you have 10 of them, let's see how many we have. 1, 2, 3, 4, 5, 6, 12, 24, 2,400 watts. 6, 7, 8, 16, 32, 3,200 watts. That's not too much for one of the small cables, so we don't need to worry. And then I will switch over to another cable network using the APC, and that other cable network where the solid fuel generator will be, yeah, we'll use heavy cables. Okay, what's coming in now? Well, they're currently slowing down. Here. 300-ish watts. You don't need a battery in this thing. It's just the battery's kind of a bonus, you'd say. I could also put a transformer here, but the transformer will consume a little bit of electricity. Oh, these guys also consume electricity. Yeah, but now at least I have the option to compare. Here we have currently 2,000 watts coming in. And now we have 0 watts coming in. So all of that is from the wind turbines. Haha! Turn an L into a W. Now we have to exchange all the cables over here with heavy cables. Good thing we're already printing these. No, we're not. God damn it, what am I doing? Why am I not printing the heavy cables yet? So batteries are not too full, but it's not a problem. The ACs are running. The other... we need... yeah, I need to complete this airlock. 2 active vents. I guess I have to print some. Ha 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 ha. Insulated pipes, 2 of them. I saw one lying around somewhere. Oh right, up here. Passive vent, 2 of them. That I will put up later. Let's try to swap out all those cables out there. So once the airlock on the other side is fine, I can actually evacuate the station properly. And then... What's happening? So this guy is acting up a bit because it expects to have a battery. You won't get one! Just so you know, asshole. Stop with your faggy tweeting, you're not gonna get it. The solid fuel generator, of course, can once again be used with chutes and such. So that you can, for example, put a whole stack of coal in there that will then be burned up one by one. And you can even then say, this guy shall only turn on when necessary. Using logic, because it too has logic connection and logic values. Yeah. We need more heavy cables. Okay, that battery is already empty. Using a lot of electricity here. Should already aim for making more wind turbines. How many wind turbines can we make here without... Oh, right, I forgot some. I just calculated with 200 watts. What about 800 watts? If I have 10 wind turbines at 8,000 watts, man. We need heavy cables there also, once the storm hits. It will be a while until that happens, because as you can see on the right bottom, this is day 1. Still the first day. But it has to happen at some point.
Lower light screens. Here comes the sun.
Sun's currently going away, man.
Sinfera on Soma FM.
No cable network found. Alrighty, let's burn a little bit of coal to see how kick-ass that is. And maybe I want to put up something here so I don't fall into the abyss the whole time. Do I have some coal on me? I don't! Okay. Let's expand the station slightly then. Not completely, I just want to prepare that somewhat. Ah. Left, just like calculated. And that's Stationeers. Okay, Okay, I need... Okay, we have the gas sensor, we have the console. We would need a disk. I could use the other one, but rather not. I don't want to run into those kind of shenanigans. I need a disk here. Well, it's currently busy in the other airlock. Ah. Your disk is in another castle. Okay, that's connected. Power is there also. We can actually take this, make this thing do stuff. Alrighty. Oh. No, we need to connect the cables. So, let's remove this door then. Will I use a glass door or composite door? Not sure. I would use a glass door to use just the same logic or whatever. Ah. Okay, now we can connect this. Ah, right, the disc, of course. But I can at least pump this empty by hand now. Oh, actually I should do that now, thoroughly, the entire station. And I should take some coal. So in case we go out there again, I will have something to burn. Next step is to pump the station empty into both directions. So I will now use the disk here and disable the airlock again, like I did before, so that I can pump the station empty. Set outward, no. Set inward is correct. Aha. And another disk, please. Obviously that's an electronic thing. Now it's being pumped into both directions. That should ensure that the station can actually be emptied. I think I should have a way to turn all of these off to save some electricity. I could place a switch down, which I then read out with this chip, which is currently not doing too many things at once, is it? I mean, what is it really doing? Housing? Import? Is just making sure the arc furnace does its thing. So it could certainly check if there's a switch that has been switched. So let's make a switch. We already saw the logic type of switch, but there's another one also. The kit logic switch. There are multiple switches, for example a dial in which you can select a value, or a push button, or a toggle switch, which kind of looks like the logic thing that we already saw. And there's also a lever kind of thing. That's the one I want to use, because then you can see very clearly what its current switch state is. Yeah, important button. You have to open this and then you can push the button. That's what the idea here is. It's also using the tutorials. That's the switch I was talking about. We already know what that's like. then that's the one I want to use, the lever. Then we have the push button, and then we have the dial, and that's all of them. So let's use the lever. I guess I only have to connect one side, but I'm not sure. Okay, now let's give this guy a name. Where is my namey thingy? Soon we're gonna have, soon, what am I saying? At some point we're gonna have the advanced toolbar, which has a complete extra row. Left all ACs, or what? Yeah. Yep, left all ACs. Because I want to address that switch in particular. So in this case, I'm not going to do load batch. I would say load batch named, which filters down from all the devices of a certain type to also have a certain name. And then if I use unique names every time, I will only get one device. You can also have solar panels and name multiple of them with the same name. In this case, then you could have 2 rows of solar panels which are oriented differently, and you could address these rows differently, but the whole row each time is very simple. Lever? I actually don't know what the hash of this one is. So, switch. And then we find the lever. Oh, that's even the one that I meant. I wanted to kind of work myself towards the kit and then from here move there, but okay. Structure, logic, switch. Just click on it, then it's on the clipboard. Paste. Now I can load the value of this guy. Load, batch, named into R0 once again, because R0 is a value we don't need that anymore, whatever's in there. From lev ACs. So from this type, if it has this name, I want whether it's, I think, open or a setting. I don't know which one it is, I think it's this one. And then depending on case, I want to just say write batch to, well, the air conditioner. What is their name? Air conditioner, here we go. Structure air conditioner, aha. Then we write to all ACs on R0 and is BIC mode R0, because I believe mode is okay, let's say mode 0, so to investigate what happens. Are we still in IC housing? Yes. What are the ACs doing? They're currently off. Okay, now they're all on. Now we'll click this start and it's being stopped. Aha. So we now found everything that we need to know. I want to, though, let these guys run normally. So flipping the lever, like, I want to invert the value. That's very simple. I just have to say, that's it. Okay, what I'm doing here, I'm comparing R0 to 0. Equal, equal. I'm comparing, if R0 is 0, then that is true. And true is 1. And the 1 shall be written into R0. So a 0 becomes a 1. But if this thing is not 0, for example, if it is 1, then this is not true. And if it is not true, then it is 0. So if this thing is 1, then it hereby becomes 0. And there's a different type of way to write this as an additional command. I don't know why they put that in there, but it exists. Actually, I know this from 68K assembly, which I learned in the 80s. With this 0 here is a value, and the computer needs to know the value. For that, the value needs to be stored in memory. It needs to be transported to the processor. But if you just say, we take this special case, I mean, comparisons to 0 are rather common. If you take this special case, then we only have to transmit the opcode to the processor, so the operation code, the processor then knows what to do, equal to 0, blah, 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 blah. So this inverts that. And here I will do this, because we know what we want to do. Export and done. So they should now all be on, and they should all be started. They are. And here I can stop them. All right. So let's see what the pressure is here. Is everything properly evacuated? Yeah, not in here, obviously. Seems like it. I mean, nothing's left. Well, then turn this off, turn the other thing off, and get some hot CO2 from the atmosphere, and then turn on the AC system and see what happens. Will it cool now or won't it? Hopefully it cools. Man, all this work. Where is the passive vent? There is one. Or even. Okay, let's pump in the hot atmosphere. Saving. Should have done that before. 0 kilopascals. Yeah. If I want it with high pressure, then I can put an active vent out there, which will really kick this thing in the balls. And maybe we need this because it will take eons. So let's put up an active vent to make that faster. See, active vents are really very actively used. You need lots of these guys. This will be on the outside. I cannot put it on the outside from here. That doesn't fly. But this is kind of the position. So we need a cable here in the air. Quasi. I will just put it up here for the second as a template. I mean, if you think about the complex things that you're doing here with this interface, it's really, really easy to use, man. Really easy. I can understand that people complain about it because it could still be improved a lot. But I cannot accept that people abandon this game just because of the interface. It's just too good. It doesn't make sense, man. The disk... Okay, let's reconfigure this guy. Oh, and I should get some steel sheets so we can continue with the expansion of the station. Gas sensor, glass door, airlock, blip. Maybe we should name these guys, huh? So often as I'm doing this. Maybe I should make the other one active also right now. Zero. Glass door, exterior. Is that so? It is. Composite door is the interior. Gas sensor, active vent. Nope, that's the wrong one again. Ha ha ha. Done. Okay, set point. Yeah, works like a charm. We need 28-ish, or rather a few more, because I also want to pave the way there. Here, these next to the station. So, keep producing. I will put the fan away again. This is cool enough by now. No! 28 degrees in here, man. But my core temperature is down now. Okay, let's go. Hey, wait, am I expanding the station here and now I'm doing the thing with the vent? Okay, whatever, it's gonna be at some point in the future. Let's not stand in the way of success by being too efficient, because it will only lead to its opposite. Oh man, I need double the amount of steel sheets. Because this needs to be airtight. Alright, later then.
Waste tank caution.
Oh, I don't have a replacement waste tank with me. Not good. Okay, that's that. Now for the active vent. Let's place it here and turn it on. Into and on. This doesn't work, I know, but soon it will. First 2 canisters, please. I still have 30 steel frames. When did this happen? Oh right, from the landing pad thing. Yeah, that has to be made still. Okay, so let's change the music here. What is with pressure in here? Oh, already 500 pascals. Already almost 1 kilopascal. Unfathomable. Let's just flip this pipe and kick this guy in the balls. One kilopascal. 2 kilopascals. Temperature 200 degrees. Good thing it's already so late. Here we can nicely see the black hole. That's actually a nice photo. Let's take that. Yeah, 200 degrees, bit hot, right? Well, before I continue... I mean, this guy keeps pumping and the pipe will then be singing, but it's no reason for concern. Nothing bad's happening. There's this overpressure protection, I talked about that at length. So, now that we have 200 degrees in here, can we do something about it? Huh. I get the impression that when it's not so hot outside, I should actually lower the target temperatures of these guys. Which seems like during the night I should then produce very cold gases and use them during the day. Something like it. Temperature here is radically increasing, meaning that thermal energy is being transported. $70. Oh man, I need to turn this guy on. And the temperature is decreasing. Okay. Okay, I was looking at the pipe. So the temperature in here is decreasing, but we're getting higher pressure. Good. We're getting somewhere, finally. God damn it. So how about the power? Still looking good. No reason for concern. How much are we consuming? 3000 watts. How much is coming in? 500 watts. So that is reason for concern. One of the next goals should be to expand the power supply. Like more wind turbines even. Real wind park. Spamming wind turbines is one of the things I like to do. It seems like we have solved that problem, so I will now risk actually opening all these canisters. So we get some oxygen in here also. This little sound that you hear when I put them away again is the sound of them closing automatically. So, 26 kilopascal, 27% oxygen. Not bad. 162 degrees though, way too hot. Are we still moving some thermal energy? What's happening? Here, for example, we have 228 degrees. And the tablet, the display here says that we still have some thermal temperature differential efficiency. I don't know why, even though the temperature is 200 degrees and we're trying to cool down to 20. How is that still working? I don't know. I want to go up to like 80 or 90 kilopascals, because cooling this down will of course decrease the pressure, and then we're down back to 65 or whatever. Of course this will decrease the ratio of oxygen that we have. So it's not yet time to breathe in here. But the plants should do their part to solve that. Question is, how hot will it be during the day? Will the ACs be able to do the job, or will the station temperature just rise? I guess one day we will have enough of the liquid nitrogen to last us for one day, and then during that 24-hour period, so to speak, we would have to get that problem solved, as we're dead in the water. What's with the power? How are we looking? Okay, this one's being sucked dry. That one is also connected. I would hope not that we experience a surprise and suddenly the entire station is without power, because I forgot a cable there. This one's empty, okay. But it's still running, huh? Okay, okay, okay. Isn't it fascinating what we're doing here? I mean, this entire room being filled with gas from this planet, filtered by these CO2 filters so we don't get some crap into this room. Then we have a line of ACs. They can't cool much, but they only have to cool one step, and the next one takes the next temperature differential step, and so forth. 500 degrees, 400, 400, 400, 320. Okay. And if you want to save some power, Bob. Cool, cool, cool. So I will now start building some setup that would allow me to drink without actually putting some water in there. Maybe I should have placed the computer a bit to the left. I will do this now. That's funny, look at that. Beep-a-dop, beep-a-dop, beep-bop. Huh. How do I deconstruct this? I guess with the drill now. Yep. This is the water bottle filler, which fills water bottles. Has two build types. You can see here the 1 and the 2 up there. So I will use the other one. Still upside down, but then I rotate it and now they are correctly written. It doesn't really matter, you know. I want the water to come from the bottom. That's looking good. Interesting, the computer still, I guess the information is actually written on the board because the board is still the same. There's a way to find out, I guess. Do we have the screwdriver? We do. Because with this you can clear boards, for example this motherboard. Honestly, it's the first time that I do this with this motherboard. And what we see, nothing. Import, so that's the, So that was written on the board. That's why the computer, even though it was dismantled, remembered what it was doing because the board itself was not dismantled. Pressure 54, 150 degrees. We're getting somewhere. Too bad we can't create more thermal energy here. But why is the difference so small? 30 degrees here. And particularly, why is it still so high over here? Well, it's shoving some thermal energy over there, so that's why that is, I guess. It's working, it's working!
Power critical.
Yeah, but the batteries are discharging, so the next problem we have to solve is station power. For now, we can just burn some coal. I will do this to show you what that looks like and how extremely powerful this is. Just turn this guy on. There's the switch and toss it in. Some more pipes. I wanted to use insulated pipes, but I'm not sure if that's necessary. Yeah, I will use those, just to be sure. Now I would need a pipe utilities kit for liquid. Do we happen to have one lying around? That may well be the case. Here we go. But all of this is engineered, you know? It's not the crafting recipe which does this thing or that thing, but it's all built from atoms, basically, and then you build your molecules, and from the molecules you build your materials, and it's fascinating. And also, it is a reality in which you run around. It's not just some kind of puzzle that you have on a screen and it's interesting, but this is your personal survival situation. I mean, they created just an unbelievably awesome game there. Those who disagree, they don't know what they're talking about. It's just true. The ratio O2 is falling and falling, not a surprise. Okay, then the hydroponics. They need some liquid connection, yeah. You could also use insulated ones here for safety reasons, but what good is that when the plants are dying from too much heat? Because you can't, well, insulate the plants, right? I would have to make an extra room for this, but this is, basically I need some kind of cold plant. Not plants, I mean like power plant. I need something that just creates super cold gas, like I explained before. How many plants do I have? Switchgrass, okay, 10. So I can plant all of these. And that's kind of risky because that's all the plants I have, but I think I can risk it. No! Yep, but still at 140. So let's go a bit above 100, I would say. I mean, kilopascals. A bit above 100 kilopascals. Stop it, and then wait until the room is colder, if it ever gets colder. I realize I need some more carbon dioxide filters. And I wanted to clean things up a bit, didn't I? So let's do that then. The grind is real. .94 kilopascals. We can also see it at the right bottom. No need really to use a tablet in that situation. Which way? The doors seem to be at the top. Okay, that's good. Come on. .100 kilopascals. You have some less suicidal tracks, please. Oh, kinda. This is garbage and goes in the garbage locker. I mean, that was less bad than we thought it would be, huh? Even though we're still pumping in hot gas from outside. Oh. It's still getting colder in here. Otherwise, let's stop pumping in hot gas from the outside. Yeah. Hey, what's happening? Why is this now expressing that it's actually bursting? Dying? I mean, what's happening there? Pollutant. Oh, okay. I forgot that during the night it's not that hot out there. So step 1, take away the electricity. Step 2, hope that no one realizes that I'm cheating now. But I shouldn't have interrupted that cable particularly. 132 degrees in this room. Still 132 degrees in this room. That goes in the garbage locker. Same. Yep, that's cleaner. Oh wait, that's something else. This is a volatile canister. 131, so it's still decreasing, but not as fast as I would have hoped. Can we accelerate this? What's the state of things? Well, 205 degrees, and I guess that, well, let's look at the, we have a temperature differential efficiency of 28%. That would be the problem here. 37%, 47%, 54%, 61%, 67%, 75%. So let's lower this temperature, for example. This should make the thermal okay, that should actually, okay, let's go to 350 then. Still? Okay. Is this increasing now? Not that I can tell. Weird. 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 Well, let's do 50 steps. 20 plus 50 is 70, plus 50 is 120, plus 50 is 170. 220, 270, 320, and then let's hope that something happens. 128 degrees. No, I wanted to see here. 27% temperature differential efficiency. Well, it's not 0%, so it's doing some stuff, but I guess the row of ACs would have to be yet a bit longer. By 2, maybe by 3. God damn it, this is extreme, and it's the night, you know? During the day there's even more, because we have to fight with even more heat. You can see the batteries are now kind of full again, because I burned some coal. Much fuller at least.
Critical.
128 degrees. Should now slowly keep decreasing. while using shit ton of electricity.
Hunger caution.
Well, I have to expand the station, actually
Air tank low.
add some more of these guys. And then we can finally start planting something so we can create oxygen. Which is indeed due time, isn't it?
Air tank critical.
So let's try to refill these. Oh no, this will actually heat them up. Or will it? Is there such a thing as an insulated canister? I don't think so. Pretty sure there's no such thing. That's why we have these canister packages. I don't know what happens if I take this water canister here and put it on the portable's connector. Will it then no longer be insulated, and will it then suffer the environment? I guess not, because I believe the connector will not have its own volume, its own, you know. See what the upload is doing. 71% of 54 gigabytes. Yeah, maybe I want to put up the tank itself, huh? Or should I dunk in a water canister? Do I have a water canister somewhere here? I will just make one. Need iron. I don't have iron. I really have to go mining again. Not funny. Now we'll dunk this evacuated empty thing into here, and then we get 1 liter for whatever reason. You can see 193, so we have 20-ish degrees in there. I will dunk this in here. Now it's empty. Instead we have that in the pipes at 20 degrees, so that's fine. And it should not be heating up. You can also see the kilopascals are increasing because water is evaporating, because it kind of needs some pressure. Let's do that again, see if something changes. We are at 1 liter. Still 1 liter. Huh, there seems to be no insulation problems here. Liquid canister. We cannot see any thermal energy exchange values here. So I guess it's fine. 123 degrees, haha. Okay, let's fill those bottles then. Okay, now it's complaining there's no more water in there. This is not really the most efficient way to do it, but it's what I can currently do with minimum overhead and without risking any kind of, you know, interference and whatever. These two are full. This one's empty. $84 liters are in there. That's not exactly much. Now it's 82 liters, so we must consider this. At some point there will not be water. And then we die. Really? Again? Shit. I thought it was full. Full enough. Could have fooled me. 120 degrees. So, how are we looking? 120 degrees, and it doesn't seem to be falling. Yeah, a bit. 119, way too slow for my taste. We need to continue the expansion of the station and indeed increase the row of these by at least 2 more. Or 3 even. Which will cost so much electricity. How much are we currently consuming? Wait, that's not right. This is right. 3000 watts. Then we will be easily at 4000 watts. Then someone's charging a battery and we're producing something meanwhile and the cable burns out. That's the situation we're facing here. So, not easy. I guess I have to connect these directly to the station batteries, to our power plant basically, which means a shit ton of cables to be laid to go directly here. Then I need to split the power supply versus the data supply so I can keep controlling them with logic. So much work. 118 degrees. How long is the video so far? 3.5 hours. If you make that 4.5, we will all have... Wait, we have 6.5 and 3.5. That makes... Well, 10. Let's make 10 hours. Makes 10 hours. So, I want to stop this right now here. We have achieved... We have 2 airlocks. This is now separate. We have an atmosphere here that will get nicer and nicer, apart from the fact that we have no oxygen, really. And the temperature is decreasing. Slowly. We have prepared the expansion of the station somewhat, so we have to go further with what we have already done, but that's pretty repetitive. We have solved the drinking problem, at least with the water reserves that we have. But I have also some fuel reserves here that I can convert. No, wait, I need to make that infrastructure first. We need to go mining again and all of that crap. So, lots of things still to be done.
Power low.
But I think it has been enough for now. Save. And good night.